Okay, guys, this is a long one, but hey, instead of a textbook, for now, we're going to do and talk about the Khan Academy assignment. So, finding measures using rigid transformations. So, rigid transformations are as follows. Reflections, write them down. Reflections, rotations. Reflections, we usually use a little r to abbreviate. Rotations, we usually use a capital R. And translations. All right. Dilate, which is a capital T. Dilations are a transformation, but they're not rigid because they change the shape, the size at least. And change the shape. They change the size. So it's not congruent. So rigid means congruent. All right, got that? So when we have rigid transformations, lots of things are preserved. You know, the areas are the same, the perimeters are the same, the sides are the same, the angles are the same. So if we know the area of ABC, we know the area of A prime, B prime, C prime. And we can use we're like archaeologists here. Okay, so that's a 4, so this must be a 4. Okay, so now, because A prime, B prime, that's AB. Okay, so 4 times 3 is 12. Don't forget to divide by 2. Because it's a triangle, the area is 6. So a lot of people already have hundreds on those, but just wanted to show you. Preserved properties. So please remember your preserved properties. Angle measure, betweenness, collinearity, distance, A, B, C, D. Angle measures are preserved. Angle measure, betweenness. If something is between in the shape, then like if I put a point here on segment AB after the dilation, or I mean, not just the dilation, but after the transformation, that point will still be between A prime, B prime. Collinearity, you remember that word collinear? If 3 points are in a line and we do a transformation, those 3 points will still be in a line. And distance is preserved. So that means, like side lengths. They're preserved, rigid transformations. And some other things are preserved too, and so we can add to the list, but these are the 4 biggies. All right. So the triangle is translated, so that means that the angles are the same. B and B prime have the same coordinates? No. They're different coordinates. The areas are the same, so areas are also preserved because the distances are preserved. All right, so go ahead and try that one. Mapping shapes, I don't really like this assignment, but it's important to know. When we're talking about congruent figures, one way to describe them is I can take this figure and I can create a mapping to put it on top of the other figure, and it blocks it all out. And that is like, okay, so they're congruent. So, how would we get WXYZ to be to map onto ABCD? You'd have to rotate it and translate it, right? So translation over the directed line segment WA. So what is a directed line segment? That is from here to here. So to get from W to A, you got to go over 1, 2, 3, 4, 5, 6, and down 1. So 6, 1. So if I took this and went, and then so then I went So I move that whole thing over like that. Just drawing a rough sketch. And then I guess I'd have to reflect it. Ah, that would work. But how about reflect it over line? So that one works. You see, I translated it, and then that's a reflection. So we could reflect it. So sequence B works. A reflection over vertical line WX. Where is WX? That's right here. So if we reflected, is it something like that? And then rotated 180. So rotation of 180. I mean, I guess that is rotated 180. About point W. I don't know if I rotated, then it's still going to have a point at point W. Yeah, I don't think that was. I could be wrong. Wait, and then a translation along WA. WA. Now that is something. Oh, okay. So let's just see. Let's say B. No, see, no, it was both. I didn't try hard enough there. See, but let's look at the picture. All right, so you can see the picture. If we, so I did that, and then yeah, and then there's the rotation, and then you just move it over. Yep. So this one is kind of a pain, but it's good. It's good stuff for you to know. A sequence as you build your knowledge of geometry. Oh no, the baby's crying. 1 second. All right. Well, now on to sequences of transformations. So we have our 4 transformations: rotation, reflection, translation, and dilation. And so we can do all of them in a sequence. And so this assignment is asking what would be preserved. We talked about the things that are preserved under rigid transformations. So what you just got to look for is you got to make sure you don't have a dilation in here. If you have a dilation, then those distances are not going to be preserved. But still the angle measure, still the betweenness and the collinearity will be preserved. Just not the distance, because everything got bigger or smaller. So which must be preserved under this sequence? You can see all these transformations are rigid, so angles, segments, yeah. Okay, so vertical stretch, that's not even a dilation. So yeah, not even angle measures are going to be preserved. Sad. All right, defining transformations. This is an important one. Okay, so we are going to do this. So reflection, this is kind of a lot. This is kind of a lot to say. So I'm going to move that to next week because that could be a whole video where we talk about reflections and then the rotations and then the translation. We're going to save that, okay? Just put that in your pocket. Let's move on to dilation. So we're going to talk, this is something we can do, okay? Dilate points. So with dilations, we have a center, and we have the distance from the center for the pre-image. Multiply that by the scale factor, and we get the image. So I call this the HV distances. All right, so we're gonna figure out the HV distances of the pre-image from the center. So here's our center. So how far down is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So B is 12 down. And then after you go 12 down, you got to go 1, 2, 3, 4, 5, 6, 7, 8 to the left. All right, so those are my HV distances, horizontal and vertical distances. Now we multiply them by the scale factor, which is 1/4. So 12 times a fourth is 3. 8 times a fourth is 2. All right, so that means to get to B prime, we start at the center. Can't say that enough. And we're going to go 3 down and 2 left. Oh, I did not start at the center when I did my directions. So that would just change it. So to go from the center, you would have to go 12 up and 8 right. Now we're going to go back to the center. We're going to go 3 up and right. Wow, that's confused. I just confused someone, I'm sure. 1, 2, 3, 1, 2. Because I didn't start at the center. Yeah, I started at the center. All right, so one more here and start at the center. Okay, so my center is 0, 0. Scale factor of 2. So how far is D from the center? Start at the center. It's 2 down. 2 down. And 1, 2, 3 left. Multiply those by 2 because the scale factor is 2. That would be 4 down and 6 left. So now I go from the center, go 4 down and 6 left. That's how you do that. Okay, so scale factor is a little formula. Scale factor is the image over the pre-image, like a corresponding side. So you see the scale factor is 1/3, and CD is 2. Well, not CD, but C prime, D prime is 2. That's the image. So the image is 2. Pre-image, we don't know. We know the scale factor is 1/3, right? 1/3. Cross multiply, x equals 6. That was easy. Use that formula, you'll get it every time. All right, what about this? Mr. Field, where's the center? Here's where the center is. So to find the center, we want to take a pair of corresponding points, like this one and this one, and we want to draw a line through them. That line will not only go through those 2 points, it will also go through the center. You can pick any 2 pair of corresponding points. You can see that it will also go through the center. All right, so that center is B. So again, pick a pair of corresponding points, draw a line through them, and that line will also go through the center. Finally, dilating triangles. We dilate triangles the same way we dilate points, and that is we go to the center, we figure out how far away each point is. So A is 1 unit to the 1 right of center. B is 2 left of center. And C is 2 up. It could be have a h and a v distance, but these only have a h or a v distance. So now we're going to multiply that all those by 4 because that's our scale factor. And then C prime is going to be 8 up. A prime is going to be 4 right. And B prime is going to be 8 left. Let's go. Go ahead. So go to the center. And then we got to put a point like 8 left. So 1, 2, 3, 4, 5, 6, 7, 8. A is going to be 4, right? 1, 2. Actually, this is going to be 2. Is 1 right? Oh, 4. Yeah. 2, 3, 4. And then C is going to be 8 up. 1, 2, 3, 4, 5, 6, 7, 8. And you can see that the green triangle is 4 times the size of the blue triangle. All right, well, there you go. We just did a whole bunch of assignments. So now you do a whole bunch of assignments and you'll do a whole bunch of learning. Great time. Bye.